Good morning, majors. So right now we're going to go over the practice test. This is Unit 4 practice test, and I believe it's 25 questions. The questions might be in a different order than yours, so you might have to skip around. The first one on mine is a proof question. It says, given A, B, C, D is a parallelogram, prove that these two triangles are congruent. I'm going to fill in everything that I have here. I have angle A is congruent to angle C. Make sure you have a whiteboard. You're doing this as well. AD is congruent to BC. And AB is congruent to CD. And they're asking us, why are they congruent? Is it SSA, ASA, SAS, or AAS? And remember, this one is ASS. There's no bad words in geometry, so this one is not okay for proving triangles are congruent. So we're going to go where there's no congruencies, and we're just going to go around, and I'm only going through the ones that they've told me are congruent, only these things that I plugged in. So I know that the reflexive property tells me that this side is also congruent, but that's not part of my proof, so I can't include that. So I'm going to go start over here, and I'm going to go clockwise or counterclockwise, and this is a side, this is an angle, and then the very next side. So I know that it's going to be side, angle, side. Remember that if there's two sides, there's only one option, okay? It says, which of the following must be true so that these two are congruent by side, angle, side? So we have a side. We have the very next angle. It has to be the very next side. Remember, the angle has to be in between my two sides. So in order for these to be congruent by side, angle, side, I need this side to be congruent to this side, okay? And it said, this one says, using the coordinates given below in triangle ABC, what is the length of XZ? So this is really important for us to look at our congruent statement. X is my first one, and Z is my last one. It has to be congruent to, remember the order matters, my first one and my last one, AC. So AC, we can use either the Pythagorean theorem or the distance formula. So in order to use the Pythagorean theorem, you're going to have to go all the way down to the line that C's on and then straight across. And I know this is like 2 units and then this is 3. Or just use the distance formula, but you have to know which 2 points to plug in. And in this case, we're going to use A and C. So use the distance formula, plug it into your calculator, and we're going to use x minus x plus y minus y. Remember that we're going to use the square root. Don't forget about the square root. That's why most people get these questions wrong, is they just forget about the square root. So my x values are the first two, which is -2 and 0. So we're going to say -2 minus 0 squared plus 4 minus 1 squared. Negative, anything negative, when we square it, -2 minus 0 is still -2, but when we square it, it becomes a positive number always. 4 minus 1 is 3, squared is 9. The square root of 13, I don't think we can simplify that. If you use your calculator and you got a decimal, plug these numbers into the calculator also, square root of 13, 2 square root of 3, and you're going to get the exact same decimal. It says, using the diagram below, which of the following is true? Which triangle is congruent to what triangle? It looks like this angle is congruent to this angle. And we have this side is congruent to this side. And we have one more thing. This side is congruent to this side. Oh, and we have another angle. Let me use red, black, I guess. Alright, so it looks like this triangle is congruent to this triangle. This in the middle, A, B, probably this is like an E right here in the middle, okay? So AEB is congruent to, A is congruent to C, E is congruent to E, and then B is congruent to B. Good, actually, that's an easy one, okay. Okay, go to the next one. All right, in this figure, AC and BD bisect each other, which means both line segments are being cut in half equally, which means A to E is the same as C to E, and D to E is the same as B to E. Also, we have the vertical angles. So, based on the information given, which triangle congruent theorem would be used to prove that these two triangles are congruent? So, is it going to be angle, side, angle, side, angle, side, angle, side, 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 side? We do not have all three sides. We do not have A, D, and B, C. So, I'm guarantee you it's not going to be D. Use your elimination, process of elimination. We actually have two sides. So, it can't be one with just one side, right? You guys need to know how to figure these out. On this one, in order for you to figure out which triangles are congruent, we need to find the third angle in every single triangle. So the third angle in the first triangle, just add up 72 plus 41, and then we're going to subtract it from the angles in a triangle need to add up to be 180. So when we add up 72 and 41, we get 113. And we know that they have to add up to be 180. 180 minus 113 is 67. So I know that this one is 67. And I know that the 10 is on the side that's opposite the 41. So if we have another 10 that's opposite the 41, then they will be congruent. Let's look at the next one. I have 67 and 41. The next one has to be 72. I have 67 and 72. This one has to be 41. And I have 67 and 41. This one has to be 72. Okay, so let's look at the 10s. Is there another one? This 10 is opposite the 72. It has to be in the correct side. So the 10 is opposite the 72, but this one's opposite the 41 degrees. This 10 is opposite the 41 degrees. And this 10 is opposite the 41 degrees, actually. So the only one that is not congruent is the one that is not opposite the 41 degrees. Perfect. Given ABCD is an isosceles trapezoid, the legs of an isosceles trapezoid are congruent, so AD is congruent to BC. Plug in your information. DC is congruent to CD. DC and CD, they have that in common. And ADC is congruent to BCD. So these are the triangles they're talking about. They're talking about like this one maybe, and this one. Separate them. And this is A and D and C, and this is D and B and C. And I'm going to fill in all the information that I have. I used red, and I said AD is congruent to BC, and I said DC is congruent to CD, and now they're telling me that ADC is congruent to angle BCD. Remember, the vertex, the angle you're talking about, is in the middle, and you guys are going to tell me why we know that these are congruent. These are our reasons. Just plug in everything that you know. AD and BC intersect at X. Okay? AD and BC intersect. They don't say bisect. So that just means that they meet at X. A to X is congruent to B to X. So these two are congruent. And C to X is congruent to D to X. And we always, which congruency statement is true? What angles are congruent? I know that this angle is congruent to this angle. And let me see, what other angles are congruent? Because they don't have X in the middle, so I know that's not the one they're talking about. This angle up here is congruent to this angle up here. So let's say angle A is congruent to angle B, but they're naming it with 3 letters. So, but A is not in the middle and B is not in the middle. So I think they're talking about, let's use this bottom angle C and this bottom angle D. But how do I name angle C? And how do I name angle D? Those are the ones you got to figure out. given MO, this ray MO bisects this angle M or PMN, so this angle is going to be congruent to this angle because it's bisected, and O bisects PON, so this angle is going to be congruent to this angle. So given definition of angle bisector, reflexive property, MO is congruent to itself, both triangles. And why are they congruent? So look at your reason, start where there's no congruencies and go clockwise or counterclockwise. Cover up the bottom triangle so that you can see you're not using both triangles, and tell us what the reason is. Go through the proof and fill in the information. Same on this one. Which postulate or theorem can be used to prove that your two triangles are congruent? Whenever we're saying this triangle is congruent to another triangle, my reasons are going to be side, 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 angle, side, angle, side, angle, 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 side, or HL. We have those 5 reasons. And this is a 90-degree triangle, so this might actually be our first HL. Let's see. So we have this 90-degree triangle, which HL, it doesn't have it in its name, but it has to be a right triangle. It has to have that 90-degree angle. And this leg is congruent to this other leg, which are the smaller 2 sides of a triangle. And then the hypotenuse, which is opposite my right angle, the biggest side, is congruent to the other hypotenuse. So it has to be the one that we don't usually use very often, that we're probably going to see on our test, HL. Because we have the hypotenuse and a leg, and it's a right triangle. If you had tried to do this just looking at the rest of the theorems, we would start over here where there's no congruency. This one would be an angle because it's inside the triangle, and then we have a side, and then we have a side. And remember, angle, side, side is not a congruence. Okay, even if you go counterclockwise. So it wouldn't work. None of the other ones would work when we use HL. Which other triangles can be proven congruent? In triagram, so A, C, B, so this triangle is congruent to D, B, C, the other triangle, D, B, C, go back to D. And then what other triangles can be proven congruent? Well, if you're telling me that this side is congruent to this side, everything about them is congruent. Every corresponding side and angle is congruent. And they're sharing this common side. And I know that this angle is congruent to this angle then, right? A is congruent to D because they're both the first one. And I know that C is congruent to B because they're both the first one. So this little part is congruent to this little part. And I know that this part of B is congruent to this part of C. And I know that this side, AC, is congruent to this side, DB. We have a lot of triangles in here, but which 2 can we prove are congruent? We're going to have some vertical angles right here. This part of E and E, vertical angles. So I see this triangle and this triangle that we can prove is congruent. So look at these triangles and find out which 2 are congruent. Go look at your picture and find out which 2 are congruent. State whether A, B, C, and AED are congruent. Justify your answers. A, B, C, and AED. So A is congruent to this part of A, and AC is congruent to AD, and DE is congruent to BC. And just because there's a 5 there doesn't mean it's not congruent. 5 is congruent to 5. So at first I thought it was going to be angle side side and it wasn't going to work. But now I have all 3 sides. Or I could have this side and then the angle in between it. So that's perfect. It could be multiple things. So this one I'm just going to show you what to do. It says triangle ABE, ADE, CBE are shown in the coordinate grid. ABE is this one, and this one. On all the vertices have coordinates that are integers, which means they're actually on the corner like they should be. Which statement is true? We want to know which triangles are congruent. Most of the sides you can just count. 1, 2, 3, 4, 5. And then some of them you're going to have to use a distance formula. So we have 1, 2, 3, 4, 5. All sides have to be congruent. We can use the slope from E to C. I'm going to go up 2 and over 1, 2, 3, 4, up 2 over 4. And right here I'm going to go from A to E. I'm going to go up 2, 1, 2, over 1, 2, 3, 4. So these two are also 2 over 4 for both triangles. And so all you really need to find out is this right here is down 2 and over 1. So this one is 2 over 1. And this one is also 2 over 1. So all you really need to find is the distance between B and A. If this right here, the distance between B and A is 5, it needs to be 5, then they will all be congruent. Given the information is sufficient to prove by which postulate? Okay, so we know that M is the midpoint of two line segments. LN, which means LM is congruent to MN, and KP, which means KM is congruent to PM. And we know we have vertical angles, so we're talking about these triangles right here probably. And this one is congruent to this one, and this one is congruent to this one, and we have vertical angles. So you're going to have to tell me, cover up one triangle, cover it up, and then read the congruence of the other one. Side, 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 side angle, side. Why? Why do we know that they're congruent? Now, I've tried to give you guys this one in a warm-up. Remember that you're always going to look at your congruent statement. So this is your congruent statement right here. This triangle is congruent to another triangle. And this triangle might be flipped, especially in your test. So don't assume that 7 is congruent to 2x plus 3 just because they're both in the upper left-hand corner, okay? So we're going to look at the congruent statement. AB is congruent to FD. So AB is this side, is congruent to FD, which is this side. Yep, 7 is congruent to 7. Perfect. And also the last two are BC is congruent to the last two, which is DE. So BC is congruent to DE. We had this one on the test last year, and some people had a hard time. So make sure you guys read that congruent statement. 13 needs to be equal to 2x plus 3, right? 13 and 2x plus 3 have to be the same. So we're going to have to solve for x, and then that's what they're asking you. What does x equal? Given these two with this and this and this, which postulate will be used to prove that the triangles are congruent? So, I mean, you can just draw two triangles. Doesn't matter the order. And then we're saying that RG is congruent to the other triangle. RA is congruent to something else in the other triangle. And angle R. So why are they congruent? You can draw both triangles if you want. Which is a true congruent statement. So just remember that the order matters. It looks like D and B both should be in the same spot because they have one congruency mark. So D and B should both be in the same spot. They're both in the middle. That's perfect. And A has 2 is congruent to C. So A and C should both be in the same spot. I guess that's it. Ta-da! Which of the following statements complete the given proof? So you're going to have a couple of proofs, and it's going to look very similar to this on your eCart test. They're going to give you like A, B, C, D, and this is pretty much what it looks like also in the SOL. It says given TR is congruent to VR, and S is a midpoint of TV. So I'm going to go through the proof. TR is congruent to VR, I plug that in. S is the midpoint of TV, I plug that in. Remember, every single time we have this word midpoint, write this on your red paper. We're going to use the definition of a midpoint. And so that gives us the definition of a midpoint. And we're going to set something equal to something. So when we're saying that S is the midpoint of this line segment, we're always going to set it equal. So TS is congruent to SV. So we're going to say TS is congruent to SV. Put a line above it. Those are sides. And that's going to be the definition of a midpoint. And they tell us the order for the reasons, so I know this has to be next. TS is congruent to VS. That's the same thing. TS is congruent to VS. Good. So it has to be A or B. We're not talking about angles for the definition of midpoint. We might do that for bisects. We'll see. Now, the reflexive property says that the only thing that's reflexive, the only thing that they're sharing is RS, right? So they're telling me the order in which I need to go. The reflexive property is the next thing, and that's RS. And you guys should know that by now. RS is congruent to RS, or SR is congruent to SR. Perfect. So they both look good. Now you've got to look at the order of these triangles. What triangle is congruent to the other triangle? And remember that the order... Alright guys, let's go to the next one. Which could be used to prove that the triangles are congruent. This little dash right here means that this side is congruent to this side. This little arc means that this part of the angle is congruent to this part of the angle. And then they're sharing this common side. So you've got to remember the reflexive property. We're going to use the reflexive property or vertical angles in any set of triangles that are overlapping. So I'm going to start over here where there's no congruencies. And I'm going to look at this as an angle. And then this is a side. And then this is a side. You can go the other way if you want. And tell me why they're congruent. Or if they're congruent. So this is what we just did on day 9 notes. We have our triangle is on a coordinate grid, and it says if CDA is congruent to ABC, what are the coordinates of D? So A is right here, C is right here, B is right here, is connected to form ABC. CDA is congruent to ABC. So we're going to look at the slope. And the slope right here from A to B, the first two, is we're going to go down 1 and over 1, 2, 3, 4. So I'm going to do the same thing from C, the first two, C to D, right? But I'm going to go this way. So I'm going to go over 1, 2, 3, 4, and then I'm going to go up 1, and this should be where D is. So you tell me where that is. These two triangles are overlapping, and I really think that you guys should get in the habit of pulling them apart when they're overlapping like this. It's not just over a side, they actually have space in between that they're overlapping. So I'm going to separate them, and I'm going to use my pencil color to separate them so I don't mistake that as like a congruency color. It's very important. And then I'm going to label my vertices. This is D, A, B, and this is E, A, and C. I'm going to label everything that they tell me is congruent. A to D is congruent to A to C. And A to B is congruent to A to E. And which could be used to prove these two triangles are congruent? They're actually sharing a common side or angle. If they don't have two letters in common, which they don't. They only have, if you look at your congruent statement, they only have one letter in common. That means they're going to be sharing a common angle. You guys see that they're overlapping. The whole angle is overlapping. So this whole angle is congruent to this whole angle. And should be easy for you guys to tell me what congruency reason that is. What else must you know to prove the triangle by, specifically they want you to know it by side equals side. So we're going to label everything we know is congruent already, or that we can assume they're sharing a common side. So this is very important that we pick the correct side. We can't pick A, B, and D, C. So this is a side. The next angle, it has to be the next side that's touching the same angle, and the side that's touching the same angle. So those two sides are the ones that need to be congruent. It's very important that we pick the right ones. The congruency statement, remember that the order matters. P has to be in the same spot that G is in, and I and Q are in the same spot, and then R and H are in the same spot. If these two triangles are congruent, remember we're just going to separate them. Use your pencil color or use your whiteboards, guys, and we're going to separate them. Label your vertices R, T, S, and Z, R, W. They only have one letter in common, not two, so we know that the common angle is going to be a common angle, not a side. And we have all these sides that are congruent. So I know that this side is congruent to this side, and I know that this side is congruent to this side. So you guys got to tell me why these triangles are congruent. Which other piece of information needs to be to prove that the triangles are congruent by angle, side, angle? So we need two angles and the side in between it. Two angles, but the side has to be in between the two angles. Okay, and the side is already given. EG is congruent to GI. Okay, and we can have an angle, doesn't matter where this first angle is, EI, E and I, so this angle is congruent to this angle, but the other angle has to be on the other side of the side. So remember, the side has to be in between my two angles, so this one and this one. Okay, you guys got to tell me how to name that angle, those angles. Alrighty, guys, that is the end of our chapter 4 review, and we'll see you guys in class. Review.